Welcome to This Explainer. I am so excited you're tuning in today because honestly, we're talking about a massive paradigm shift in how we write code. If you've ever felt like your PHP scripts are just this long, endless, linear set of instructions that just gets harder and harder to manage as your project grows, well, you are definitely not alone. Today, we're making the leap. We're shifting our entire mindset from writing simple procedural logic to modeling actual real-world entities using PHP Object-Oriented Programming, or OOP for short. It's going to completely change how you architect your applications. Seriously, have you ever found yourself completely lost in messy, procedural spaghetti code? You know the exact feeling. It's hundreds of lines of functions, scattered logic everywhere, and trying to track down just one tiny bug feels less like programming and more like untangling last night's dinner. Well, let's dive into this, because object-oriented programming is literally the hero solution we've been looking for. It is specifically designed to tame that chaos once and for all. Now, what's really interesting about this is how it contrasts thinking in actions versus thinking in real-world entities. Procedural programming forces you to focus purely on step-by-step functions and logic. Do this, then do that. But OOP, it completely flips the script. It revolves around objects that combine data, which we call properties, and behaviors, which we call methods. So instead of just writing a script that does things, you are designing entities that know things and can actually perform actions. Here is our toolkit of programming superpowers for the day. First, why choose object-oriented PHP? Second, blueprints and instances. Third, inheritance, reusing your code. Fourth, interfaces, the coding contract. And finally, magic methods and autoloading. Let's get to it. Section 1, why choose object-oriented PHP? Let's see how this builds our foundation. Why should we even bother making the switch, right? Well, these benefits represent the holy grail of software design: modularity, reusability, maintainability, and just a much better mapping to real-world systems. Think about a giant school system. Instead of having loose variables for a student's name just floating around and some random function somewhere else to pay a bill, OOP lets you group all of that perfectly. You create a student object. It holds its own properties, like an ID, and it has its own methods like enroll or pay tuition. The whole shebang related to the student lives with the student. It makes your code incredibly clean. Moving on to Section 2, blueprints and instances. So, how do we actually create these entities in our code? Well, it all starts with a class. A class is simply a blueprint. It's absolutely crucial to remember that it is not the actual item itself. It's the exact schematic for building it. Imagine you're an engineer at a massive car factory. The class is the paper schematic that defines, hey, a car must have a brand property, and it must have a start engine method. Now, you can't drive the schematic on the highway, obviously, but it dictates exactly how every single car built from it will look and function. And that brings us perfectly to the object itself. If the class is the schematic, the object is the physical, drivable Toyota rolling right off the assembly line, built straight from that car blueprint. In PHP, you just use the new keyword to create an object from a class. You can create one Toyota or 100 different Toyotas, all from that single blueprint. They will all have a brand property and a start engine method, but each object acts as its own independent, unique instance. So the crucial point here is how we protect the data inside these objects. And we do that using 3 access modifiers: public, private, and protected. I mean, you wouldn't want just any part of your application changing your car's engine status directly, right? Public means the data or method is accessible from anywhere. Private rigidly restricts access to only the class itself, which is a fantastic way to hide complex internal logic. And protected kind of strikes a balance. It allows access within the class and any subclasses that inherit from it. These modifiers are literally your first line of defense in keeping your code secure. Section 3, inheritance and reusing your code. Be honest with me. Have you ever copied and pasted the exact same block of code across 5 different files just because they did almost the exact same thing? Yeah, we've all been there. But inheritance is a brilliant mechanism that allows a class to reuse the properties and methods of another class. Imagine you have a general vehicle class that has a method for filling up fuel. Now you want to create a motorcycle class. Instead of writing that fuel method all over again from scratch, your motorcycle can simply inherit it from the vehicle parent class. No way around it. It's a real game changer for eliminating code duplication. In PHP specifically, we achieve this using the extends keyword. You'd simply write class motorcycle extends vehicle. Now, if your subclass needs to tweak how that inherited method works, say you're filling a much smaller motorcycle tank, you can use method overriding to redefine that behavior. And if you ever need to specifically call the original parent's version of a method, you just use the parent ... keyword. Actually, scratch that. There's one vital rule you absolutely must remember first. PHP supports single inheritance. That means a class can only inherit directly from one single parent class at a time. Section 4, Interfaces, the coding contract. So what if you have a massive code base and you need a guarantee that different classes, even completely unrelated ones, all behave in a predictable way? I want you to think of an interface as a binding legal agreement. It declares methods, but it does absolutely zero implementation. It's just an empty shell of rules. For example, if you create a payment interface, it might dictate that a pay method must exist. If your new credit card payment class signs this contract or implements it in PHP terms, it is absolutely forced by the system to include its own working version of that pay method. If you forget, PHP will literally throw an error and stop your program. It is strict, but it ensures perfect consistency. And this brilliantly illustrates why you might choose an interface over an abstract class when you're planning out your architecture. Interfaces only allow declarations, no actual code implementation. But a class can sign as many of these contracts as it wants to. Abstract classes, on the other hand, are kind of a hybrid. They can have both empty, required methods and fully coded methods that subclasses inherit. But remember that PHP single inheritance rule we just talked about? Yeah, because of that, a class can only extend one abstract class. Keep that in mind as your cheat sheet for architectural planning. Section 5, Magic Methods and Autoloading. Okay, I want to ramp up the energy a bit here because we are moving into the real sorcery of PHP. Let's talk about the automated tools and magic methods that do all the heavy lifting behind the scenes. PHP actually has built-in predefined functions called magic methods, and you can always spot them because they start with 2 underscores. The construct method automatically fires the exact millisecond an object is created, which is perfect for setting up initial data. Get and set allow you to dynamically intercept when someone tries to read or write to a property that is hidden or just doesn't exist. And toString lets you dictate exactly what happens if someone tries to echo your entire object as a string. They allow objects to behave incredibly dynamically, but a quick word of warning, use them carefully. If you overuse magic methods, your code can become incredibly hard for another developer to read and trace. Next up is autoloading, which honestly feels like pure magic when you first use it. In the old days of procedural PHP, the top of every single file was a nightmare of 20 different include statements. Ugh. But with autoloading, you define a function using SPL_autoload_register. When PHP realizes you're trying to use a class it hasn't seen yet, it pauses, triggers this register, automatically finds the correct file, and includes it dynamically. It completely eliminates those messy include statements and keeps your application perfectly organized, loading only what it needs, right when it needs it. So let's bring all of this together by showing exactly why everything we just covered matters in the real world. These OOP principles, they are the hidden backbone of the web's biggest platforms. WordPress heavily relies on classes for handling posts, users, and plugins. The entire Laravel framework is built on a massive, elegant web of interfaces and autoloading to provide scalable architecture. Massive e-commerce platforms like Magento rely deeply on inheritance to manage complex product catalogs. By mastering these concepts, you're literally learning the exact same language used to build the modern internet. So I want to leave you with this provocative thought. If you had to sit down right now and architect a massive, complex school system from scratch, how would you design your very first class blueprint? What properties would it hold? What interfaces would it need to sign? I challenge you to take what we've unpacked in this explainer, start sketching out those classes, and maybe even experiment with namespaces and autoloading in your next big project. The blueprint is in your hands now. Happy coding and keep exploring.